Hello everyone. We are looking at complex number chapter and it is a phase 3 chapter and we are at exercise 1. Exercise 1 are the basic question where we practice those questions to just get the idea of the simple theory of the initial part of it. So the questions are all directly based on the concepts that we do here in the class. So this question, as we can see, it is based again a direct question where we have to find the square root of a given complex number. So we know that a complex number square root will also be a complex number. So we just start with that. So let -8 minus 6i b is equal be the root of this. Let that be as a plus ib. So, and then we square both sides. -8 minus 6i is equal to a square minus b square plus 2abi. Now, if we compare the real part and the imaginary part again, 2ab is equal to -6 here and ab is equal to -3. Put a into b, get a quadratic, and then we can find the values. So either we can do by quadratic or by simple hit and trial method also. But I'll just show how the quadratic works. 2ab is equal to -6. That means ab is equal to -3 and a square minus b square is equal to -8. So we can put a square minus b square is 9 by a square is equal to -8. So a to the power 4 plus 8a square minus 9 is equal to 0. This is the quadratic which we need to solve for. So a square is equal to -9. So a square minus plus 9 into a square minus 1 is equal to 0. So we can factorize, we can use quadratic formula, whatever the case may be. So here we see a square is equal to -9 or a square is equal to 1. Now, the catch here is that in the very definition of complex number, yes, we are in the complex number, so you can argue that why we are rejecting it. Because in a complex number, the real part or the imaginary part of the complex number is always a real number. So even if it is a complex number, let's say this is equal to z, then real part of z or imaginary part of z, whatever that is, that will always be a real number. So a and b are always real. So a square is equal to -9 will not give us a real number. So we have to go with a here. A square is equal to 1. So when a is equal to 1 or a is equal to -1, we get two solution for this. And once we write a is equal to 1, then b is equal to -3. If a is equal to 1, then b is equal to 3. Combine both to give the square root. So square root is 1 plus 3i. Sorry, 1 minus 3i plus minus. This will be the square root of the complex number. So this is the set. This is a set method. We always have to start with a complex number, let the root be another complex, square both sides, and then what we have been doing since the beginning, we compare both sides. In this case, we get a quadratic in a square. And now here is the key that we do not pursue this result because a is supposed to be, or a should always be a real number. So this will not give us a real number. So we only take a square is equal to 1 and the two solution from there on and the value of the corresponding value of. So these are our two roots. These are our roots -1, 1 minus 3i or -1 plus 3i. Thank you.